Welcome to this DDi CADcast. My name is Bill Mitchell, and today we will cover what's new SolidWorks 2014 for Assemblies. This is going to be part one of a two-part CADcast. The first thing to take a look at is the ability to create shaded drawing views with high-quality edges. In an assembly environment with thin components that mate against each other, in previous versions of SolidWorks you can see that the edges would actually bleed through on the drawing. Switching over to SolidWorks, going to my view palette, you can even see that on the preview that the edges of those components show through. When I drag and drop a view in and then go to the display style, switch it to shaded with edges, I have two radio buttons, one for draft quality and one for high quality. As I toggle back and forth, you can see that the high quality edges actually hide and give you a more realistic view of what that component looks like. The next enhancement in SolidWorks 2014 is the way that the feature manager structure is displayed in large design review. Whenever you open up an assembly in large design review mode, it essentially gives you a graphics preview of what the model looks like. In previous versions of SolidWorks, it was difficult to actually get a handle on what the assembly tree looked like. In SolidWorks 2014, we now have the ability to see patterns as well as all the components, so we can get a clear view of what the assembly structure looks like without actually having to load everything into memory. The next enhancement in SolidWorks 2014 is the ability to include rotational movements in exploded views. This ability is only available in assemblies, but you can rotate a component either by itself or as it transitions away from the model. So let's go ahead and take a look at another assembly. Going to my configuration manager, I can go ahead and create an exploded view just like I've always been able to in SolidWorks. If I select a component, have it transition away from the model, you'll notice that I get a ring around the model, a ring around the component. If I move the ring, I can tell it exactly how to rotate around as it transitions. Go ahead and add a couple more movements. So when I select a component, I can also just drag and drop the manipulator to any surface to designate that as a rotational axis. So dragging and dropping to the hole, you can see that I can actually rotate this item forward. Let's go ahead and take a look at what this animation looks like. Now if I need to go back and make a change, I can always go back to my exploded view, edit the feature, and then if I select a given exploded view, you can see that there's a new icon that indicates that it has rotational movement. If I edit that step, I can designate the explode direction and the distance, just like I've always been able to do with SolidWorks. But now there's a new addition of an explode axis, direction of rotation, the angle of rotation. If I select a component, I can also tell it to rotate about the component origin, meaning that rather than selecting a particular rotation point, it's going to rotate about whatever that component's origin happens to be. The next thing to take a look at is some changes in the mate user interface. We can now apply standard mates from a context toolbar, add smart mates to the command manager, set the sensitivity of our smart mates. You can also pin the mate property manager, and then the default mate type behavior has changed in SolidWorks as well. Let's go ahead and take a look at another example file. So in previous versions of SolidWorks, if I were to control select two components, I would be presented with the shortcut menu to mate. In SolidWorks 2014, there's now a context menu that gives me the ability to select a mate directly without having to go into a separate dialog. Smart mates have also been enhanced. Whenever you hold down your Alt key and grab an edge, SolidWorks will actually look for an edge to mate to. But the delay in which you move as you start moving across the assembly file might be a little bit fast, and so it's a little bit difficult. In SolidWorks 2014, we can now adjust the sensitivity of those smart mates. Go ahead and search through my options. I can adjust underneath system options, performance, smart mate sensitivity, I can either make it slow or off altogether. Off is going to be similar to the default behavior in SolidWorks 2013. The default behavior of mates is also changed. Now if I control select two edges, and go to the mates command, notice that it automatically creates a parallel mate. In previous versions of SolidWorks, it would have tried to create a coincident mate and errored out because those items are not can't possibly be coincident. In SolidWorks 2014, it will now also include parallel mate as a default mate option. Going back to smart mates, I can now also add smart mates to my command manager. If I look up the smart mates command, I simply just have to drag and drop, and it'll actually add it to the command manager. Previously, smart mates were only available by selecting the move option and finding the smart mates option within the dialog box. That was difficult to get to. The next thing to take a look at are some new mate features. We can now specify limit mate values in design tables, create new slot mates, lock rotation for concentric mates, and then create spherical and curvilinear mates. So let's go ahead and take a look at the limit mate and slot mate feature first. Coming into SolidWorks, you can see that on this particular fastener, I've got a limit mate. The limit distance, if I go in and edit that mate, you can see that I've got the distance and then the minimum and maximum values. This is now something that we can add to a design table. So if I go into my design table, you'll see that I've got a limit distance value, the lower limit, and the upper limit. You can also just add some different values. So next time that I add that configuration, the limit mate distances will be applied within that mate. Let's go and take a look at the slot mate. If I go into my mates, mechanical mates, I've got a new option for slot mate. If I select a cylindrical face and a slot feature, you can see I've got the option to constrain it either to be free to move within the slot, center in the slot, move along a distance within the slot, or a percentage of the slot length. SolidWorks will look at the assembly model, and you can see that I can just move this up and down. Now the features have to be equal radius on either side, and the edges of the slot have to be parallel to each other. But with that said, I can select an axis and a face, create a slot mate, and even though this is not a cylindrical face, this hex profile can move freely within, or this hex component can move freely within this slot. Looking at this component, you can see that there are some slot mates applied, so that whenever I move one component, the slot mates are stacked in such a way that it allows the component to move almost as if the move component physical dynamics were enabled. Some examples of geometry that would not qualify for a slot mate are slots with square edges, or one round edge, something that would be curved, or things that would not be equal or parallel on the sides. Let's go ahead and take a look at the lock rotation for concentric mates and the spherical mates. Coming over to the spherical mate, or to an example, I can create a mate between a spherical face and another spherical face, and I can either make it tangent or concentric. And this allows that component to roll within that socket. Coming over to a different example, I can select a spherical face and an edge, make that tangent. You can see that that component is allowed to just ride along that seam. spherical face and a conic. If I apply a tangent mate, it will be tangent to the very edge of that surface between a spherical face and a toroidal shape. Or to this spool shape. I can also create a mate between a spherical face and a sketch entity. As long as it's a consistent sketch entity, parabola, spline, something like that, it'll allow us to create a tangent mate between the spherical face and that entity. Coming back over to an assembly file with some bolts in it, you can see that I have a bolt. I can lock rotation for all of my different mates. So if I go into this particular mate, for my concentric mate, right click on it, I can lock rotation or unlock rotation. Lock rotation basically is giving it the ability as if you had mated the front plane of a bolt to the another plane within the cylinder that prevented the component from rotating. I can apply the lock rotation as I create the mate as well. So if I select two components, get into the mate command, I can either lock it on the pop-up or within the feature manager itself. I can also lock rotation on a global basis. So coming to my assembly, looking at the mates folder, I can just right click, I can lock concentric rotation for every concentric mate in the assembly, or unlock it, so that the components are free to spin. Next thing to cover is some enhancements to the assembly mirror feature. More mates are going to be copied with a mirror feature, so that as you create a mirror feature in the assembly, whatever mates are applied to one component are going to be applied to the other. Let's take a look at this assembly component. You can see that if I view my center of mass, the default behavior is that a mate is created so that the center of mass is aligned. However, if I go into this assembly, unsuppress a component, you can see that because it's mirrored, the center of mass shifted to the left with the addition of the other component, but it didn't give me the effect that I was looking for. The components are actually mismatched. So if I come back into my mirror component feature, I've got the ability to either use the center of mass, which calculates the center of mass of the component series that are selected and then mirrors that about the designated plane, or I can use the new bounding box center, which will create a bounding box, calculate a bounding box around the components, and then ensure that the symmetry is also on the other side. For more CADcast topics, check out our YouTube channel at www.youtube.com/DDi CAD or our tech blog at www.ddicad.com/tech center. Thanks for watching.